Hello and welcome to another live session at the Reactors. My name is Vav and I'm the Program Manager at Reactor London. Before we get into this session, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, this session will be recorded and will be available to view on our Reactor YouTube channel in the next 48 hours. And today's session is on your first AI project, working with data with Korey. And I think it's going to be an absolutely amazing session. So with that, I'm going to get Korey to take the stage. Hi, Korey.
Hello. Thank you, Rob, for the introduction. I'm Korey. I'm a cloud advocate here at Microsoft, and I'm joining you from the gray and dark Stockholm, almost winter, not really fall. But I'm always curious to see where everyone else is calling from. So do let us know, and I appreciate everyone already kind of joining even before the session. I appreciate all the excitement. But yeah, let me know where you're calling from, because we're talking about data, and data affects everyone all across the world. I'll start with first talking about the last episode, and I don't know if everyone has joined from the last session I had called just Your First AI Project, but in that session, I had this slide where I talked about 9 different steps of building with AI, and I said a quote, and I wish I could just like play the exact clip, but I couldn't find exactly where I said, each of these steps could probably be a whole presentation. So I am a man of the people. I'm here to deliver on that promise. Today in this chat, we will talk about specifically around getting the data and working with data for your first AI project. But just seeing where everyone's calling from, this is super interesting. Wisconsin, Belgium, Canada. I like that. Canada, big fan. And Helsinki. So very, very close. No one from Stockholm yet, but I hope if you're from Sweden, please let me know. So in today's session, we're going to talk about a couple of things. We have some goals for this. First, we're going to talk about where to get the data. Hello, Stockholm. Hello. Where to actually get data. Data is all around us. We say data is so important. There's probably data being generated from this session and collected somewhere for analytical purposes. So data is all around us. But when you're starting out and you're building your first AI project, it still can be quite tricky on finding where to get data that you would like to work with. We're also going to talk about how to understand the data. So once we have the data, how can we explore it and find insights on what we want to do to actually build with our AI project? And then why and how to clean the data. So, we hear this term data cleaning all of the time. Why is that important, and how to actually do that once we have located the data that we want to work with? First thing we'll do is actually we need a project. So, this is called Your First AI Project. And if we don't actually have a project, it really wouldn't make any sense for this sort of session. So I want to talk about Netflix. If there's any Netflix fans, let me know in the chat. Let me know your favorite Netflix show, because I'm always looking for recommendations on what to watch next. That's the biggest mystery of all time. But what we'll do with Netflix, I think it's an interesting data or place to pull data from, because you can do a couple of things. We can do things like recommendations. So, as you use Netflix, you will probably constantly get suggested the next things to watch. And that's all using kind of AI or ML behind the scenes. So if we have some Netflix data, maybe we can build a recommendation system that's, maybe more interesting or better for certain users. We can do personalization. Like, I didn't know this until I used someone else's Netflix, but Netflix is a completely personal experience, even from the images and the titles as far as what they show and the trailers that they show to each user. So they're taking all of that data and personalizing your experience to make sure that you watch the next show, essentially. So maybe we can do some personalization type models. We can also do NLP or translations, like mentioning, we have a very global audience here that speaks probably many languages, but if, we have one Netflix app and we can pretty much watch any show we want in any sort of native language through the powers of NLP and machine translation and things like that. It's a super cool thing. It definitely opened my eyes to different content and movies and shows that I've never watched. Like, I'm a big fan now of Korean dramas. I don't know if anyone is here on the watching on the stream, but I can do that now because of the powers of NLP. And maybe we can even get a little even crazier and like use large language models like GPT-3 to even write scripts, or to craft new Netflix shows based on the data that we get from the transcripts of a Netflix show that we've seen or liked. So we have a lot of options. That's why I want to start with Netflix, and we're sort of making it up as we go as far as what we want to do. But all of these things all start with data. So that's why we were talking about data at the first start of this. And the first task of data is actually to get the data, right? So one place you can get data is obviously in a database. If you have access to something like this, you can build structured queries depending on your database type. And you can get real specific on the data that you want. Let's say with Netflix, and we want to actually pull in the ratings or reviews of something like that. I can build a very targeted query and be able to pull in that information. Normally databases also has a large amount of data, which is super convenient when we're building AI models that are data intensive, so that when we are looking for different ranges of data and things like that, we can pull in right from our database. And it also has updated data in certain cases. We won't talk about this world of machine learning operations, but a lot of the times when we're building an AI model, we think, oh, we'll train the model, and then that's the end of the story. We'll deploy it, and that's the end of the story. But one of the most important things around bringing AI projects into production is updating or retraining the model. So if we have data that's in a database that gets updated based on maybe user actions or things that take place within an application, then we can actually better retrain our model for the current situation or the current environment that our model is operating in. So there's some advantages of doing a database, but like I said, this is really targeting to your first AI project. So not everyone has access to a database full of data that's completely structured and large amounts of data. So, but if you do have that, and I know Netflix is experimenting with their advertisements or advertisement plan. So I'm going to put in a small advertisement in this presentation. But we have last week actually, I did another session specifically around using SQL, so SQL database and data visualization, instructing you how to actually build the queries and use data visualization to understand that data. So if you are interested in that, there's the link there. Please don't leave to go watch that now. Please stick around, and then you can watch that, of course, later. In certain cases, so I'm a Python programmer, and Python is close to my heart. But in certain cases, there are also built-in data sets to different libraries that you're using for AI or machine learning work that sometimes people don't know about. So scikit-learn has one. If you just import the database datasets module, you can have datasets like a wine dataset, the digits datasets, or like hand-drawn things, as well as PyTorch also has some equivalents using the Torch vision. And I think I would like to say these are like gym data sets. And what I mean by that is not that they're connected to any sort of training or gym side of things, but I think they're great data sets for kind of practicing or getting understanding how these libraries work. But oftentimes maybe they miss the mark on what you're trying to achieve or predict. So feel free when we need to like explore different data sets to go outside of these built-in data sets. And that's when we start talking about downloading a data set. And that's probably for when you're building your first AI project, either whether it's a hobby project or something maybe you want to do within your job or work, but you want to not use the company's data to do so. You can download data sets on the internet that are quite good as far as quality, and most of the time completely free, hopefully. The classic one of this is the UCI machine learning repository. And I would say I call this the classic because I think if you've taken any university course in data science, machine learning, or AI, they're most likely going to use a data set from this repository. It's a very clean data set. The only thing I would say or recommend is to watch out for, depending on the data that you want to use, if there are some sensitivities around the time of that data, since this has been around for a long time. I don't know exactly how long. You can pull data sets that have been published or were created in the early 90s. And let's say we're working with Netflix on data like when Netflix wasn't around. It's not going to be really helpful then to build movie reviews on maybe video movies that a data set that was created before Netflix even existed. So there's also that you can like filter on the year of the column, and you can pull in the most recent data sets, which could be again important for your project depending on what you want to do. But I mean, for instance, I was looking at a train data set before this. Like trains more or less look the same, but yeah, things get updated. Technologies, things like that. So maybe again, you want to be very aware of what when your data set was created when you're using this resource. There is the Google Dataset search engine as well. It works like Google. You type in what sort of area or where you want the data. There's some recommendations like COVID data, which is quite popular to build prediction models on now, or understanding the effects of COVID. And again, it actually also links to another resource we'll talk about later called Kaggle. There's also the OpenML data sets. And again, if you just Google any of these names, you can find the links pretty easily. These are, again, really great data sets built from the OpenML community and gives you a wide breadth. So showing here, there's like 4,000 available data sets. So again, really wide breadth, but it might also still not necessarily, you can't find the exact data that you're looking for. So the kind of data set royalty, if you will, is a site called Kaggle. So if you're first working with AI and data science or have never done something like this, this is probably the most recommended place to download data sets. So this is what we will do in today's session. And if I want to, I'll go ahead and just search Netflix. And you can see I get 317 different data sets that are connected to Netflix, which is exciting, right? I mean, I can start pulling in all of these data sets, and my imagination goes wild as far as what's possible with all these data sets. But we will focus on just one data set in this case, which is called the movie data set for feature extraction and prediction. So we will do some predictions or some maybe recommendations on this data set. And just to give you a quick snapshot of this, so we have things like the movies, year the movie was released, the genre of that film, the rating that was given, or what the audience is currently rating that film or show, one line to describe it, the stars, so the people, the cast that are featured in there, and then the votes, like how did the audience actually express voting on these things. So there's already certain elements you can probably pull from this data set around recommendations or building some sort of genre personalization, things like that, if we have other user data, or suggesting what you might like next to watch. So we have the data set. Now the next step is actually understanding the data. I gave you a quick snapshot of what that looks like, but that doesn't really give us all of the insights that we might need to actually start working with AI. And when we talk about understanding a data set, we want to make sure that this is a good data set. And that gets just thrown around quite often, Love. Define a good data set to work with. So how does that get defined? What is a good data set? So I said there's 4 C's of a good data set. And I know this breaks all of the rules of like the rules of 3. You need to have 3 of everything, and that's most persuasive. But I think there's 4 that's really important here. So I'm happy to break that rule and to explain to you. First, that the data set is correct, that you're actually using right data, and we'll go more into detail of this. That there's good coverage, so it covers a good spread of amount of data or what is relevant to your problem. That the data is consistent, that we'll talk about when we talk about labeling and feature extraction, and that the count. So a lot of times when I speak to people building their first AI projects, they always ask, how much data do I need, really? Whether that's someone, again, working on a part-time project, or a developer just experimenting with AI, it really gets fixated on how much data do you need to work with AI or training a model. But I think if you have the 3, correct data, good coverage, and consistent data, you have more flexibilities on just getting the count. And I really want to encourage most people to focus on the top 3 and then focus on count, because if you have inconsistent data, it won't matter how much data you have, really. So correct data. So this is actually pretty clear. If you have the wrong data, And what causes wrong data? Well, sometimes things get collected or recorded incorrectly. Data sets sometimes are built by humans, or whether even if it's scraping an API or scraping a website, there could be a bug in the code that pulls in the wrong data. And for someone that's working with large data sets, they might not actually spot that, and they still will publish a data set, let's say on one of these websites, and it's really up to you as a person building or working on the project to actually work on the data there, to clean the data and find where the wrong data sets are. This often happens in measurement data, or anytime you're sort of measuring something or understanding, or like whether it's like a length or a distance, and you can imagine like things so like 8 meters or 8 millimeters is quite a difference. But in a data set, this is a very small, easily made mistake. So one of the things I would recommend when you're building or looking at data sets is looking at measurement data and making sure those are all correct as far as what you're measuring there. And why do we do this? Why is it important? Well, if you have wrong data, that really can skew your predictions, especially again if you've completely in a whole different category recorded something wrong that makes a big difference. The model will pick up on that and understand that maybe this is something way more important than what it should be. You won't get the actual reality. So let's look at our data set and see if we can find wrong data there. I have given you this example of working with pandas. This isn't a pandas session. So exactly this, you can use different tools, whether it's R. I can imagine you would use this also within Excel as well. You can do all of these sorts of functions. So just to give you some tangible of like how you would do this, I'm doing this in pandas, which is a Python library. And the first thing I will do with working with pandas is load that data set into a data frame, which is what pandas uses to really manipulate and explore the data easier. And then I use this function called head, which gives me basically a snapshot of the first 5 entries of that data set. We already showed the screenshot in Kaggle of what the data looks like, but now that we actually have it here in code, we can see that there's different columns. So movies, genre, there's one line, the stars. But again, I think a lot of the times wrong data is presented in the ratings or in measurements. So we see that there's a rating here, and this could potentially be a place where wrong data would be either collected or stored wrong in this data set. So it's best to start exploring that. I can do this by using .where, basically where what I will do here is take the ratings column and compare that to if I'm trying to find any rating that's over 10. Because what I can tell from the data set that I showed, this looks like it's all out of 10. We don't have anything over that. And even the best movie in the world, which is, I don't know, I won't express my opinion on what the best movie in the world is, won't be rated over 10. So if we have something that's 11 or 15 as a rating, we probably have some wrong data. So this is what this line of code is doing. And I can just not leave a cliffhanger, but we don't actually get any results for running this thing. We get a lot of not numbers or things like that. So this is actually a good result that there is no wrong data, but this is a great way to check if there's wrong data in your data set. So missing data is another problem. Missing data is oftentimes just blank values in rows, whether that might be certain columns in the row or just maybe there's only one result that's in that data set. And it happens in a lot of data sets, so it's something to definitely look out for. This could be caused by a variety of different reasons, whether the data set is unavailable or it was not recorded at that time, or if there's certain categories they don't apply to that particular data point. Most data sets just leave it blank because it needs to continue. They think that it's still important to collect that data point. But again, we will continue to move on. So we need to find and make sure that if there's any missing data there, we know where it lives. Because again, this still can have a negative effect on training. And depending on the models or ways you're using that, you also maybe get some errors for that side of things. So again, super important to be looking for missing data. So how do we find missing data in our data? So again, using pandas in the data frame, we have some functions around here on is null. And I'm also going to use sum. What this will actually result to is 2 things. One, it will look through the data set to find if we have any null or missing data. But instead of just showing me all of the data points, I want to just find the certain columns that have the most or the totals at least from the missing data points. So I know maybe I should one, build a model that predicts around those columns, or B, I need to find ways to fill those data, find a way to fill or replace the missing data. So using this, I get a result like this, where I have all of the columns within that data set and a count of all of the missing fields. So you can see, if we look here, year to the date that the film or show was released, it's relatively high, but we also see that quite high in gross, which I guess is around the amount of money or gross income that the show received, as well as rating. So that's really interesting, because if we want to build a model around predicting what are the best films for a person or a user, we want to make sure that we have ratings pretty available across our data set. But again, using this is null is a good way to give you a snapshot of what work you might need to do to sort of clean the data set, which we'll also explain later on. Now is coverage. And what do I mean by coverage? Well, there's a couple of things. Is one, to understand like how big the general population is. And what does that mean is, like, we're working with Netflix data, but maybe we want to build an AI model that predicts the best movies for someone to watch. So the general population is all of the movies available, and the population that we're using is only a subset of that, which is the movies on Netflix. So I don't know how many Netflix movies are actually on Netflix, but if someone can do a quick Google search, I will happily love to know, comparing that to how many movies have been released. But I imagine it's pretty high, but things change quite often with Netflix. And then what is sort of the spread of the labels that we actually do have? So, we have things like genre on this data set. Well, how does this actually relate to all of the genres that are available? And do we actually have good coverage of each of those unique labels, where we can see comfortably that most of them are fairly represented? So we don't want to have a whole data set full of comedy movies, for example, and then be able to release those things. And I've just gotten as Netflix has over 17,000 titles globally as of April. Thank you, Marco. You're the Google hero of today. I'll share that as well. So 17,000 movies, and we'll look at when we talk about count how many movies we have in this data set. So coverage in our data, we have things like we can use things to understand how many unique values are in that column by using a data phrase called a function called nUnique. And this will actually give us the unique values of each column. And now we can see in the genre, we have 510 unique values in there. Again, this is probably where I'm most concerned about our coverage. Like, we want to make sure we can recommend movies in a good range of things. And I can also do things like, okay, I can look specifically in that genre, the unique value, and find that. And I could see, and this kind of leads on, but I could see that, okay, these are split. They have like, each movie has almost 3 different genres attached to it. The action, crime, horror, which sounds like a great movie genre. And, I know Netflix also gets very creative with these sorts of things. So again, just showing what those are and how the spread of those things will help you understand your coverage of your data and know that you're actually you're getting good representation across the board. The next is consistency. So consistent labels is what we're really looking for when we talk about consistency. So we want to make sure that labels are actually formatted in the same way. Again, humans can label these sorts of things, and there might be many ways. You can type something in all caps. You can type things in lowercase. You can type things in camel case. All these ways that you can label one piece of data. And so we want to make sure these are actually consistent and formatted in the same way, so the model can pick and categorize those well enough. We want to make sure that the labels describe the same thing. I always bring up the example of sales data. So sometimes when we're doing working on like sales deals, for example, things may be closed, things could be won, things could be in process, things could be signed. All of these things could be one phenomenon in the world or mean the same thing to someone, a user, but we have all these new different labels there. So you want to make sure that these all make the sense and they're all describing the same thing that you're building your model around, whether it's predicting sales, predicting closings, things like that. and that the labels are actually human understandable. I know we're building an AI model here, and humans aren't going to be involved in the actual predictions, for example. But if you can't understand the labels, if they have some weird like number convention on saying like that this is a black thing, or this is instead of saying horror film, this is a 005008 type film. That's not going to be really helpful if it's overly complex. So you also just want to make sure, even if it has to be complex, that you have understandings around that. So we'll look at inconsistent labels in our data. I did a little cheat and already kind of peeked into the data, so I know where some areas of where inconsistent labels are. But we'll look at the years as being an opportunity for we can identify where inconsistent labels are. And we can do this by using the data frame again and looking at just the unique values of the year column, and we can print that out. What we'll see here is now we can see that there's different ways of saying the year, because some are TV shows that go on for a length of period of time, or films that are at least released one. But one of the things I do want to hone in on, and I'm again not really sure why, and we could probably look through the Kaggle data set because there's probably some README or description of that, is that we also see that there's these like I and two for Roman numerals. What does that mean? And I don't know, but this could be a way that we can make this more consistent by removing these values. We'll talk about that again more when we talk about cleaning the actual data set. So lastly is count. This is again what we get most of the questions about. How much data do I need? And the old law is more data equals good, right? We just need more data, keep feeding the model more and more and more data. And I want to say more good data is good, which is also very simplistic, but it really is straight to the point that more good data, which we already talked about around having good coverage and consistent and being correct, is what you want to focus in building your data set on. Or if you want to get more data around that, is making sure that you have coverage, you are using consistent labels, and they're actually correct data. So better data equals better predictions. That's really the main focus here. And we want to make sure whatever we're trying to predict, or whatever environment or product that we want to use this model for, that data is going to be as relevant and as real as possible when we're doing the model training. So how much data do we have in this data set? Well, we can use a simple data frame function called shape. Shape 0 will give us the row count, which is 9,999, which, again, looking at the 17,000 titles, it's pretty good. I mean, it's not perfect. It's not all of the titles, but I think, it's good representation of Netflix data as far as available. And then we can also use shape 1, which would give us the columns, which could be important just to show like how many features you have available to make predictions and things like that. So that's also another good area to look for. So I wanted to stop here and talk about the ethical concerns, because last time I did a presentation on the first AI project, I shamefully did not specifically talk about ethical concerns when building with AI. And I think it's super important, and specifically around data. So I want to bring this up for this audience as well, because I think, again, even if you're building something like a Netflix recommendation, you might think, there's no issue with that at all. There won't be any ethical concerns. But any model or anything that you're working with AI, there's a sheer amount of scale and speed that predictions come up. You still want to have an eye on ethics. So some ethical concerns around data. Where did the data come from? Like, I put you to do some really nice, clean data sets from hopefully good people that have not, stolen this data or, obtained it in any illegal ways. But even so, where did the data come from? How was it sort of processed? These could be all important things, especially when we're talking about user data and those debates around privacy. It's super important to focus on and know where your data has come from. How was the data collected and from who and what? Again, similarly, but like how once we did, identify Netflix, like did we go into someone's account and we just scraped all of that? Is that like good data collection practice? Or do we, use an API that was publicly available? These are all quite important things for quality. But on an ethical side of things, if you're collecting data from let's say, banking data, and we pulled it from, banks that are of certain zip codes and things like that, that will be, maybe it will point us and skew our model to making predictions. We try to apply the model to the general population. So again, another thing to focus on is like how this data was collected, but then who and what the data was collected from. And then, does this data represent the population fairly? And I talked about a little bit about coverage, and in this case, we're talking about genres of films, but also when we're talking about making decisions on, again, financial decisions or things like that, or societal impacts, we want to make sure that however this model gets applied, that those individuals are also represented in the data set. Because if not, then this would be a huge issue when the model is making predictions on those individuals or their actions, or guiding them through some decisions, however you would use the AI model. And if you don't have any representation of that, then fairly in the actual data set, you have a lot of issues. And you can Google all of these issues that you've probably seen before around computer vision, not identifying people of color, things like this, because the data didn't have it available. No one asked that question of, does the data represent the population fairly? So to save yourself from being a press release waiting to happen, always ask this question when working with data. And what was the process actually creating the labels for the data? I mentioned, in our data set, I think this is a pure web scraping thing. But in certain other cases, like, we get the intern to label the data, or we get the college student to label the data. And, humans inevitably will make mistakes. So just knowing that process of how labels were generated, so that if there's any mislabeling of particular data points that could skew your model and make predictions that are unethical, where to look and maybe improve that process. And these are all questions that you will need to ask or should ask even before building the model, right? Once you have the data, start asking these questions and getting these thought processes, because this is going to be important for making your model an ethical model that's deployed out in public or your project. So data cleaning now. So handling missing values is the first thing we'll talk about. First is also understand how much data is missing. So what we did in the earlier example, when I used the data frames and I saw the unique values or the sum of unique or missing values in each column, then I could understand where I should focus on getting new data. And then understand if there's any sort of patterns or why there is missing data. So if I said, we're missing 6,000 genres of films, maybe at that time the service that we used to scrape Netflix or the API went down. And that's just the sole fact that, okay, well, that's why we don't have the data, and we're making another new API request and we can get that data. There's always going to be reasons on why you might be missing data. So it's really important to first understand that. So if you need to fill that data or find other values, you can do so easier than other methods. But if you can't fill them, the simplest thing, if there's not a large significant number of missing rows or missing values, is just to remove them. If they're not as important to the amount of predictions the type of predictions you're making, and there's not a significant number, easily removing them will make your life much easier as you're working on your AI project. But if you still need to fill them and it's a large amount of value, there are other ways to do that, whether it's taking an average or mean of a certain data. So let's say in our data set, we can take the average rating of horror films and apply that to any horror film that's missing the ratings. So taking similar classes and their data and applying to them would be important. And also median is another way you can sort of look for data, and that might be suitable replacements to missing values if you again need to backfill or fill those values with something. So handling incorrect data. Well, the first thing to do to sort of find incorrect data, I would recommend is using data visualization, whether you're building pie graphs or bar graphs, anything that's kind of in your data visualization tool set, because they will probably be able to show where you can see some clear outliers of data. And most incorrect data, well, not in all cases, can kind of skew or look as outliers. So pointing to that, using data visualization and not necessarily going through each row, using maybe pandas, it will be quite tricky. So data visualization is also a great way to spot incorrect data. And then you can spot any patterns. Like I said, there still could be reasons, whether it's the source that you use was unavailable, or there are just completely new data points that are out there. Like we're talking about Netflix, like Netflix constantly is updated. Maybe we have incorrect data for the new releases of films coming out this fall because they're just not available. So just spotting patterns and understanding that will be super helpful for you. And then, like missing rows, sometimes it's just easy to remove the data. Instead of trying to fix it, if there's some clear ways that you can't get around that data or the incorrect data, just remove it from your data set. And Pandas is a great way to do that by just removing those columns or rows. Handling bad labels. So first, you need to find the bad labels. So I like to use wildcards with this. Pandas has a wildcard type of search where we can find basically ways or queries where it's like certain thing, but not exactly that. So for instance, I could probably find a certain genre, and then I could see that, oh, well, maybe this one is capitalized, this one's in all caps, this is spelled wrong, but it's similar, like horror with an E, I don't know, something like that. So this using wildcards is a great way to spot bad labels. And then you can ensure that labels and make sure again that the labels that you're using describing the same data, right? Like I mentioned, there probably be multiple ways if you're working with certain data to describe a event happening. You want to make sure, and you can either talk to someone who's made the data set or produced the data if you're not sure that these data sets are all, these labels are all connected. And then replace them with the correct labels. It's probably the most straightforward way to do that, right? If it's in all caps, lowercase everything, or uppercase everything, that's probably the quickest way to handling bad labels. So handling bad coverage is another one. Again, coverage is super important. We're talking both from a quality and accuracy standpoint, but even an ethical side of things. First is to understand the distribution, much like what I did in the Pandas example, where I understood how the unique values of each column, and then investigate the reasons on why you might be missing or having bad distribution. For example, there's certain limitations that this exists in nature or just natural. So like if we are talking about predicting Netflix subscription rates, we probably would expect that people who churn or people who cancel their subscriptions, it doesn't happen every single day. I don't know. But we probably don't want that much, or we probably wouldn't expect that high of data if we're talking about a business or something that's selling, and we have all of these, failed projects, for example. So understanding that maybe bad coverage or bad distribution is a natural phenomenon is important, because also when we're talking about analyzing the results of the model, we should optimize for certain metrics that aren't just about accuracy. Because if we have a data set again where we have here's all of the great data of us, winning deals or winning sales deals, and then we only have 5 that we didn't succeed on. That's probably natural for the way that this operates in the real world, and so we shouldn't just say, oh, we should use accuracy as our prediction model. But we'll talk about that in a later session. And if you have bad coverage, sometimes it's easier just to group less represented labels together. So in the case of Netflix, maybe we have horror films and Halloween films, for example. And I know Halloween films could cover different, maybe there's a Halloween love film out there. But we want to, since we don't have many Halloween films, we just group them together and make one horror film Halloween category or label. Again, using tools like Pandas or an R, you can make ways to find and replace these sorts of things. So we discussed data. This is, again, ensuring that you're using good data, have good coverage, and you're preparing yourself for a model. So now the big finale is to build an AI model. That's your cliffhanger. That's your Netflix cliffhanger. We will cover that on the next episode of this series of building your first AI project. So stay tuned. Wherever you found this session, we'll post on the Microsoft Reactor groups, and we will talk specifically now we have this data set, how to get a model to start training on that and looking at the predictions. But the journey doesn't have to stop here. We have a nice module in the Microsoft Learn platform about introduction to data from machine learning. So covering a lot of the topics that I talked about here as a review, but also some other methods around one-hot encoding, for example, when we're talking about regression problems, what that actually means and how to actually do that in your data set. So you will still learn some new things and new methods and get more hands-on with working with data, which I saw some requests in the chat around how can we start working with it now. Good luck. Again, this is all focused on your first AI project. AI is not easy all the time. If you do have any questions, feel free to ping me. I'm on Twitter as well as on LinkedIn as well. But we'll take any questions now. And I see Raphael has a question around hands-on experience. Let me see if I can show that. Cool. Will there also be a hands-on experience? So this would be the best place to start, to be more hands-on and use some of the methods that I described in this session. There's also Microsoft Learn some sessions around pandas. So if you're interested in data cleaning and exploration, you can use the Microsoft Learn platform and be able to even make your own notebook and follow along. So online graphical user interface for this? No, but I will be able to follow up and at least make this into a Jupyter notebook, all of the examples here, because that's basically what I use to generate all this. So if you're familiar with Jupyter notebooks, that's kind of the GUI or GUI for working with this sort of data.
That's it. Yeah, there you have another question.
Yeah, which type of project do you suggest for IT thesis leading to possible data science master's degree? Well, that's a great question. I would say start with the most simple type of projects, AI ML, which is probably around regression and clustering problems. Those are, again, simple but very effective models to work on. When I was doing courses and studies, that's kind of where all of those things sort of started at. But they also solve very critical business problems. So I know you mentioned you're using a thesis to lead to a master's degree, but maybe eventually you have aspirations to work in industry. And if you can show that you've built a model making predictions or solving a business problem, that's super helpful. And I find the easiest or the most effective, at least, place to shop around for is regression type problems. A great question. And good luck as well.
I think that's it, Korey. I don't think we have any more questions.
Okay. Well, thanks, everyone. I'm super disappointed I didn't get any suggestions on Netflix shows. So this is your last chance to, hawk your, sponsor your favorite Netflix show so I can start watching some things. But yeah, thank you all for joining. And yeah, feel free to ping any more questions you might have later on. You can find me in these places. Bye. Attack on Titan. Thank you. Thank you, Raphael.